Today we're going to talk about the wonderful wriggling world below us, earthworms. Earthworms are hermaphrodites, otherwise known as having both female and male reproductive parts. This allows for earthworms and other worm species to reproduce at quicker rates, which is important for their survival. They usually mate after heavy rains and when the ground or soil is wet, and this is why you see a lot of worms on the sidewalk and the streets after a heavy rain. It may surprise you to know that earthworms actually have no lungs or eyes. They breathe through their skin, and this is also how they sense their environment through light and touch and move their way through soil. On each segment of the earthworm's body, located on the ventral side, bristles, also known as setae, can be found. These bristles are exactly what help earthworms move about the soil because remember, they have no eyes, and also stay upright. It also allows them to perform one of their main functions, which is soil aeration, which we'll talk a little bit about later. Here's a picture of the anatomy of an earthworm broken down into a simplistic view. Here we can see their hearts. Yes, hearts. They actually have 5. So what they lack in eyes and lungs, they definitely make up for in hearts. Earthworm hearts are not like ours, however. They actually have aortic arches, and these are what help circulate their blood as they move about the soil. Let's talk a little bit about vermiculture and vermicomposting. Vermiculture is the intentional farming or cultivation of earthworms for various uses like vermicomposting. In vermicomposting, earthworms break down dead or decaying organic matter and then turn it into nutrient-rich soil, which can then be used to grow crops. Earthworms use their bodies to dig tiny little channels in the soil in order to aerate it, which we talked about earlier. Aeration of soil helps improve drainage, which overall helps improve crop growing and makes it a more effective process. The nutrient-rich compost that is yielded by these earthworms through their organic waste can be used for farming, gardening, and other growing purposes. The waste that comes from earthworms are known as castings. These castings can be shown in the picture to the right. This is how the soil gains beneficial nutrients from the earthworms. As of late, you might have come across this buzzword, microplastics. Microplastics are the remnants of any plastic container, and let's face it, plastic at this point is unavoidable. What the image to the right shows is that everybody has some form of microplastics found within their bodies. From one of the articles that I studied, I pulled this quote. Global plastic production reached 4.9 billion tons in 2015, and by 2025, that's this year, 11 billion tons of plastics are expected to end up in the environment. You might be asking yourself now, how do earthworms enter this conversation? While research is still in its early stages, promising data has arisen. So let's start with the good. In a quote pulled from one of the research articles that I looked at, it says, recently, the contribution of earthworms to plastic degradation and their capability to swallow smaller plastic fragments, known as microplastics, has been emphasized. The worm physically changes the size of the microplastics and enhances microbial activities to increase the possibility of degradation. From another article, I pulled these quotes. The biological degradation method is preferred, i.e., what earthworms are doing to soil, over chemical methods because of its compatibility with the environment. According to several studies, earthworms did not die in soil contaminated with MPs, microplastics, and neither did their rates of consumption nor their rates of growth. As with everything in life, with the good must come the bad. To quote one of the research articles that I looked up, their ability to burrow and eject their product into various levels of the soil structure may contribute to the spread of microplastics in the soil structure. In layman's terms, what these articles are saying are the downsides of using earthworms to decompose microplastics in our soil is the potential to spread these microplastics to other soil ecosystems and also through the water. So, why go green? In green agriculture, both at a smaller and larger scale, it is important to overall promote a sustainable and more ethical earth. We owe it not only to our earth, but also the workers who are dealing with pesticides and other harmful chemical methods of removing microplastics and other harmful materials in our soil to make better composts. If we can cultivate and maintain such a practice, i.e., biological degradation through earthworms, we can extend not only our lives through the food that we eat, but also fight degradation of our planet. They say you are what you eat, and so what we put in our ground is what we eat. And it's important to not only be mindful of single use plastic consumption for its impact on our soil and our earth, but also develop sustainable practices for the health of our society, future generations, the planet, and all of us living in it. In truth, there's so much more research to be done and at larger scales to see the ultimate benefits of earthworms decomposing microplastics in our soil. So it's up to us to decide whether the good outweighs the bad.